We end the course finally here on Module 15 with what we call one-way ANOVA tests, or one-way ANOVA F-test for short, ANOVA. And so what we do in an ANOVA, we're going to compare a quantitative variable, okay, with different groups. So it's like a um, two sample t-test, but we have more than two groups. So for example, in this picture, you could see through exploring quantitative data, we'll see the ratings different movies got: PG or lower, PG-13, TV-14, or rated R or mature. The rating, so we're comparing more than two groups and a quantitative variable, right? So we have these different levels, right? Movie type and then the rating that goes with it. So in this case, what do we notice? But I see some overlap, but is there enough overlap, or is there enough there to say that the ratings are the same, or are they different, right? And that's the question that we want to answer with an ANOVA test. So it's like a two sample t-test, but like it says here, but we're using more. And what it stands for, more than two categories. And what it stands for is analysis of variance. And its purpose is to see if there's a difference in means when analyzing two or more populations. In other words, we want to compare quantitative results between multiple groups. Is there an association between user scores and their rating? That's what we're looking for. And that association means that there's a difference between them. Again, we use that word association a lot. And so one way sometimes we look at that on ANOVA is kind of like we're looking through experiments and treatment groups, right? That's one way we can do it, and where we have more than one group. So for example, 10 participants, no treatment, 10 were giving some other strategy, and then 10 were given some other strategy, in this case hypnotizing versus no treatment versus some type of treatment to it. So see, you have three groups to compare. And what we're doing is we're going to compare the quantitative value of those groups. And so the null hypothesis is that the means are all equal to each other from the groups. They're all equivalent. That would be the null hypothesis. The alternative is that at least one is different. Again, it's similar to the chi-squared one, but now we're looking at a quantitative variable comparing multiple groups. And what we're looking for, again, in this case, an F-test statistic is calculated. Again, that's similar to a Z, a T, or chi-squared distribution. So something to keep in mind. And there are some assumptions we need in order to run this test. And again, that's for more advanced classes. Here, we're going to assume in most cases the assumptions are met, but the data needs to be normally distributed, right? That would be one. They have the same variance, or again, the standard deviation. Their distributions are similar. So again, that's what that would look like. Now, if we were going to run the full test, that one that we saw here, we don't have the data. We're just going to show you, and then I'll show you an example with data. You would say here you have the different content ratings. You have the user ratings, right? The actual mean values, and that's what you see, the mean symbol. And we're saying they're all equal to each other. At least one of them is different. Again, if you have the PDF, you could click on the data set and run the test. You'll see at least one of them is different. That's the alternative. You have the ANOVA, the alpha equals, and then you get the test statistic, p-value, and then it's that same decision. Since the p-value is less, in this case, greater than alpha, since we're using 0.01, we do not reject, right? If it was 0.05, we would reject, right? Again, that's that confidence level, right? As we think about it. So there's insufficient evidence to conclude that at least one of the means is different. So we would say there's no difference because it's kind of close, right? They look a little different, but they're not. And now statistically, we have that evidence. So what this looks like in the ARTIST stat, you would go to one-way ANOVA, that's near the bottom, comparing several groups. You will see, as it pops in, you're going to see the option to, in our case, we would need to enter in the data. This case, you'll provide your own data, or if you have the summary statistics, then you can enter in the group labels, the sample size, the mean and standard deviation, If you have that statistics already, if you're going to provide your own data, then you're going to put the variable name, how many groups you have, the group label, and then you actually enter in the data. You can also look at the distribution through box plots and histograms. So this is again when we're comparing more than two groups. Here's an example from the textbook, just looking at, let's see, let's pick a category that, again, treating anorexia. You have 3 different treatments: cognitive treatment, family therapy, and control treatment. And then you can see either with box plots, you can see it looks like there could be a difference, right? Family therapy seems to be doing it, but I do have some outliers with cognitive therapy, right? And so that's why it's hard to determine, are they actually different? You have the descriptive statistics here, and it looks like this family therapy has a mean greater than the other ones, but is it statistically significant? You look here, the test statistic, and then the p-value. So because that p-value is low, we can then determine that one of these means is different, right? They're not equal to each other. There's something going on. There's an association between cognitive treatment and its effectiveness, right? And so that's what we're looking at. And that variable, again, is weight loss in this case. So there seems to be something with that. Again, you can look at the different distributions, but I think the box plots are the most telling. You can kind of see the distributions there. But that's what you're going to do to run ANOVA when you get data values. You either have all the data, or most likely you have the summary statistics, and you compare. But if you were doing your own analysis, like a research, you probably would be your own data. But in our problems, many times you get the summary statistics. That's it. We're done with the course. Awesome.